Hello, this is Blake McBride, and today I'm going to be showcasing my final project for CS411 Database Systems at the University of Illinois Urbana-Champaign. My project title is educ.io, which I've taken to calling Educio, and before I get started I'm going to give a high-level overview of basically what Educio is and who it's useful for. So Educio is an interactive data visualization tool and dashboard that researchers can leverage to explore various research topics in the academic world. Upon selecting a keyword, you can see that this is presented through a series of widgets, and we're going to take a look at how this actually works in a few moments. But for now, the main objective for Educio is to give an interactive dashboard that researchers can leverage to understand trends, as well as like the top faculty and universities within their area of interest. Educio uses Express.js and React for the backend and front-end frameworks respectively, and we also make use of several NPM driver packages for connecting the external databases to our data models that are stored in the backend. These include SQLize, MySQL2, Mongoose, and Neo4j driver. If you're going to be running Educio locally, there is a quick start guide that it details all of the dependencies for both the backend as well as the front end here. And there are also comprehensive setup instructions that you can refer to for getting this up and running. I'm not going to be getting into this all that much in this presentation. I'm going to be focusing more on how Educio works. So if you need to refer to these, they're out here for you. And if not, please continue to follow along. So the next section down here it relates to the build for Educio. And before I actually cover this, I'm going to go ahead and do a demonstration because I feel like that's going to help put into context sort of how all of these different components that we talk about in this section fit together. And so I'm going to do that now. Okay, so we got a new terminal window open here. I'm going to go ahead and CD into the backend to start running the local server. And to do that, all you have to do is type in node index.js. And we can see that our server is running on port 3000. Just to check to make sure that that worked, I'm going to quickly switch over and go, and we can see that it populates right here, so that's all good. Now I'm going to switch back, and I'm going to actually open up a new terminal window. And here I'm going to CD into the front end in order to run the client side. And so to do that, we're just going to run npm start. And this will start up our front end here. We get this error message saying that there's something already running on that port, so we're going to go ahead and say yes. That way it opens up in a different one. And we can see here that our dashboard is pretty empty right now, but that'll change in just a second. But we can see that both of these clearly work to start the local server as well as display the front end for the end users. So this dashboard is pretty simple and intuitive to use. All of these widgets that you see here actually update all at once. These are all the querying widgets for the dashboard. Each of them corresponds to a different database within our external database structure. But all you have to do to see something populate here is type in your keyword of interest. So if I type in computer vision here, we can see that all of our widgets have populated, and each of them gives us some different information regarding the keyword that we entered. And just to demonstrate that this isn't a one-off thing, I'm going to go up here and change our research interest from computer vision to machine learning. And we can see that we have different data populate corresponding to that keyword. I can do the same thing for psychology, so it's not just limited to computer science fields, obviously, but this kind of gives you an idea of how the dashboard works. I'm going to go into describing what each individual widget on this dashboard is doing and how they all work and what backend database they are connected to. Since this is a computer science class after all, I'm going to go ahead and change this back to computer vision for the purposes of demonstrating this dashboard. It'll hopefully be a little bit more relevant to you. The first widget we have over here is the total faculty, and this number represents the number of faculty members from our databases who have this keyword, computer vision, selected as their research interest. So every faculty member in the database can have one keyword as their research interest, and this is the number of faculty members who have computer vision as theirs. Next, we have total publications, And this represents the total number of publications that have been published with this keyword. And so publications, it's a many-to-many relationship with keywords, where a publication can have many different keywords, and there are many keywords that can be assigned to many publications. But this means that there are about 3,700 publications that have computer vision as one of their keywords. And next we have total universities, and this one's a little bit more interesting. So this is the number of universities who have faculty members who have published publications related to this keyword. And so there are 86 universities showcased here. The next widget down is the number of publications represented as a time series. So basically give an idea of how popular is this keyword, is it gaining traction? This is showing the number of publications over time that are related to that keyword. And then down here, we have the top faculty ranked by the number of publications. And so this functions a little bit different from the total faculty number that we see up here. This one is based off of a faculty member having a research interest that is the same as the keyword, whereas down here, this is just based off of publications. So a faculty member makes a publication, and if it's related to this keyword, then it gets tracked as one. And so we have the faculty members, the top 5, that are ranked by the number of publications they have in this research area up here. And the same logic applies over on the right with our top universities by publications. So again, these are going to be the top 5 universities ranked by the number of publications that come from faculty members who are affiliated with each university. Lastly, over on the far left side, we have 2 widgets here for updating our backend databases, one for adding a new faculty member and then one for adding a new keyword. And I'm going to go ahead and just to verify that I don't have it already stored, we'll go ahead and select star where name is Blake McBride, and we see we don't have anything populated. We can do the same thing for MongoDB. See that there's nothing here. And then last, we can run this, and we'll see that there's no node with Blake McBride. But then if we come back over and we add a new faculty member with my name, and then we go back and check, we can find there's been one faculty member added with my name on MySQL, and we can do the same thing with MongoDB. You can see it populate there. And finally, we'll go ahead and we'll try to match right here, faculty name, Blake McBride. And you can see that it's represented right here. We can see this graph too. And we can do the same thing over here with add new keyword. Here we'll add a new keyword called Blake, and then we'll go back and we will check in our database whether or not this worked. So we can see that the keyword is populated here on our MySQL, and we can do the same with our Neo4j. Okay, so hopefully by now with this you have a better understanding of kind of what the dashboard looks like and how it's accessed from a user perspective. What I'm going to do now is I'm going to go into more detail with each of these widgets and explain kind of the logic of how each of these is working, as well as just the general architecture behind this application. So here we are back at the build section in the README, and you can access this for yourself it's in the repository. But basically the overall architecture of Eduquio has a user, like we just did, inputting a keyword to the dashboard. And then once this is done, this is an event that's tracked by controllers, which will send an API request over to the server. And with the API layer, this is actually drawing the data from data models that we've defined in the backend, which I'll demonstrate in a few. But these pull data from each of our 3 databases, MySQL, MongoDB, and Neo4j, and ensures they're all up to date and aligned with our backend side. And this will send data back through the API. It'll be hosted on the server side for the controllers to access, which will then pass that data to the handlers, which do all the manipulation as far as visualization and processing of what's sent back from the server. And then once this is finished, the handlers will update the dashboard in real time for the user to then, be able to see whatever has populated for their specified keyword. Briefly, I'd like to call attention to the different database techniques that we're using in this application. So we were supposed to use three, and the three that we chose to use are constraints, stored procedures, and REST API for accessing databases. We have constraints defined in each of our data models, which align one-to-one with the external databases. So ensuring this alignment means we need to create the primary and foreign keys, specifically for tables that have relationships between them, like faculty and faculty publication models. So we also have stored procedures, and these are basically stored bits of code that are reflected in each of our data models for extracting data carefully from the backend. And these are parameterized, obviously, with the keyword. So these are stored so that we don't have to keep referring to them over and over again. And finally, we have REST API, which is obviously used to kind of power this whole dynamic between our client and our server. We use this API to extract the data from the external databases that are supplied on the server side. And this concludes the project presentation for Educcio. I didn't have time to get into absolutely everything I would have liked to have covered. I did spend a lot of time building this project, but if for more information on any of the database techniques or the data models or setup requirements or the extra credit capabilities for this assignment, you can refer to comprehensive details that have all been included in the README. And with that, I hope you have a great rest of your day, and thanks for watching.
For this feeling